Hi everyone, let's take a look at the following example. Find the limit of x minus 1 divided by the square root of 10 minus x minus 3 as x is approaching to 1. Step number 1, if you plug in x to be 1 in this case, and again, never skip step 1, what happens is x equals to 1, so it's going to be 1 minus 1 divided by the square root of 10 minus 1 minus 3. Now here comes the mental math. If you think about 1 minus 1, that's going to be 0. If you think about the square root of 10 minus 1, that's going to be 9, or the square root of 9, which is 3, minus itself. So you end up getting one of the 7 types of indeterminates, which is basically 0 divided by 0. Now this signals to you, you can move on to step number 2 or step number 3. Step 2 is really factoring. Step 3 is multiplying by the conjugate. And in this case, the reason why we're going to apply step number 3, which is multiplying by the conjugate, is because of this square root symbol. So again, anytime there's a square root, this signals to you, think about the conjugate. If it's a cube root or something different, that will be a different technique, which we'll show you in a different video. But again, in this case, because of this square root right there, it signals to you, you have to multiply by the conjugate. Now, there are 4 cases when it comes to the conjugate, and the one we're applying here goes as follows. So think about grade 10 academic math when you did difference of squares. When you think about a squared minus b squared, that's basically a minus b times a plus b. So we're going back to that concept. If you look at the denominator, the square root of 10 minus x minus 3, the conjugate is the square root of 10 minus x plus 3. Again, you have to multiply this by the square root of 10 minus x plus 3 divided by itself. And effectively, you're doing 2 things. Number 1, you're multiplying it by 1. So you're not really changing the actual value. And number 2, you're changing the form in such a way that's going to help you find the answer. So again, if you think about this, this is going to be the limit as x is approaching to 1. Do not expand the numerator. There's no need for that. And you just copy it as is. If you look at the denominator, a minus b times a plus b is going to be a squared minus b squared. So that's going to give you 10 minus x minus 3 squared, which is going to be 9. Now, on the following page, we're going to continue this. And the key concept is when you cross something up from the top and the bottom, you're one step away from getting full marks. So here we go. Let's move on to the next page. This is going to be the same as the limit as x is approaching to 1 of x minus 1 times the square root of 10 minus x plus 3 divided by, and again, if you simplify the denominator, this equals to 1 minus x. Now think about this carefully. When you look at the top and the bottom, x minus 1 divided by 1 minus x is exactly negative 1. This signals to you you're on the right track. Now, just in case there's one student watching this and you're thinking, I don't get it. Why is x minus 1 divided by 1 minus x equal to negative 1? So on the side note here, again, you can think about this mentally. You can write it down if you like. X minus 1 divided by 1 minus x is the same as factoring that negative 1 to the front, which will give you x minus 1. And now when you cross that out, that's going to be negative 1. Now you go back to the first step of limits. You plug in this case, 1. So this is going to be the square root of 10 minus 1 plus 3 divided by negative 1. Here comes the mental math. The square root of 10 minus 1 is going to be 9, or the square root of 9 is going to be 3. 3 plus 3 is going to be 6 divided by negative 1, which is going to be exactly negative 6. Now, how do we know this is right? You don't want to just kind of stop here and say, well, I feel good about this and I'm going to hand it in. You really want to confirm by activating that dual mindset. So what I would say is draw a graph. So when you go back and you graph this, again, a dual mindset means, can you solve this algebraically and can you confirm this graphically? What happens is this. If you really look at the graph, y equal to x minus 1 divided by the square root of 10 minus x minus 3, you would discover the following. There's a point at 10 and negative 3. So let's say this is going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3, or negative 3, I mean, right there. So I'm going to label this point for you so that you have a reference. It's going to be 10, negative 3. And you would discover this other point, which is exactly at 1, negative 6. So 1, negative 6, 1, negative 6. And you can connect the graph, roughly speaking, something like that. Now, what does that really mean? If you look at the left limit, it's going to approach to negative 6. If you look at the right limit, it's going to approach to negative 6. So the key concept behind limits, if your goal is to get 100% every single time, did I say every single time? My recommendation is you solve it algebraically and you confirm it graphically. I hope this makes sense.